All right, algebra students, guess what? Time to do some math and rock it out. All right? So this is Mr. Stewart. We're going to talk about an arithmetic sequence. Arithmetic like arithmetic, sequence as in things that go in order. So let's warm up with the plan that we see in front of us of finding the pattern of option 1 or question 1, 2 boxes, 4 boxes, and then 1, 2, 3, 4, 5, 6 boxes, 8 boxes, 10 boxes. So a sequence is a pattern with numbers. In this case, we are increasing the number of boxes by 2 each picture. Now, an arithmetic sequence is a pattern of numbers that increases by adding or subtracting, because subtraction is technically adding a negative. So adding a negative, subtraction, the numbers can go down. So look at example 2. We go from 12 to 9, which is subtracting 3, and then 9 to 6, which is subtracting 3, and then 6 to 3, which is subtracting 3. If it's the same amount of subtraction each time or addition each time, that is an arithmetic sequence. So the explanation for this pattern is subtracting 3 from one number to the next number. So our formal definition of sequence is an ordered list of numbers where each number is separated by a comma. That's our sequence. So 12, 9, 6, 3, it's a list of numbers separated by a comma that shows a pattern. To be a little more specific, if it's an arithmetic sequence, kind of like arithmetic, that means our sequence is changing by adding. So an adding pattern exists between all terms of the sequence. Now keep in mind, this adding pattern could add a negative number, like we did in example 2, and adding a negative would make the numbers go down. So technically it's adding a positive or negative. Now this number that we add over and over and over is called our common difference. The reason why it's called a common difference is because we take a previous term, a term in our list, and subtract it from the one before it. So we would take 9 from our example 2, subtract 12, and find our common difference of negative 3. Or we could take 6, subtract the previous term of 9, and get a difference of negative 3. Or we could take the 3, subtract the previous term of 6, and get a common difference of negative 3. Our common difference means it's the same number we keep getting over and over and over when we subtract any term from the term before it. Our common difference is the value that determines how the sequence is changing, whether it's changing by adding a number or whether it's changing by subtracting a number. So let's look at some examples and determine if our sequences are arithmetic. If they are arithmetic, we want to find the common difference. So we have some terms, 5, 11, 17, 23, 29. So what we're supposed to do is take a term, we'll take the second term 11 minus the first term of 5. That'll tell us what the common difference might be. Then what we can do is take the 17 term minus the previous term and subtract again. And we notice it's the same number, but it can get tricky. So we need to keep checking. We'll do 23 minus 17 and make sure it's the same number. Make sure the differences are in common to each of the terms that we have listed. If the common difference is truly common, then yes, it is an arithmetic sequence. Now you might be able to see these very quickly on your own. You might have been able to look at 5, 11, 17, 23, and 29 and say, oh yeah, just adding 6, adding 6, adding 6, adding 6. That's really what we're checking for. If the numbers get too big or too weird to try to figure out in your head, then what we do is we take the second number on the list minus the first number on the list to get our first difference. Then we go to the next pair. We'll do 12 minus 19, and we're going to check each term to see if the subtraction of the term before it leads to a common difference. So if we do have the same difference for each one, then yes, it is an arithmetic sequence. So we check 15 minus 5, and then we check 45 minus 15. And no, that is not a common difference because when we subtracted, we got different answers. Now, if I'm going through this too fast, remember you can pause whenever you need and restart and rewatch this video as many times as you want, especially if you want to hear my wonderful voice over and over and over. Example 4. Let's take 4 minus 16 and check for our difference. Then we take 1 and 4 and check for our difference, and they are not in common. So I would like you to pause the video and test to see if number 5 and test to see if number 6 are or are not an arithmetic sequence. If it is, I want you to find the common difference for me. So pause the video, get the test and the subtraction going to see if it is or is not a common difference, and then hit play again. Okay, so you should have both of these taken care of. What you're testing for is whether or not the difference between the previous term and the current term keeps giving you the same result. So if I take the current term of 6 minus the previous term of 5.25, and I keep checking that for each term and the term before it, we do get a common difference. So yes, it is an arithmetic sequence. So that's how we tell whether it is or is not an arithmetic sequence. Now, it's not always this easy, so let's look at some other things that can happen. For example, our notation. Now, a sequence notation commonly uses a subscript. Sub, like a submarine, is down low. Script, like something that is written. Okay, so it's written down below. An exponent is written way up high. You're used to seeing things like exponents, like x squared. So if you have x squared, that is an exponent. That is technically a superscript. We are talking about subscripts, so they are written down low. So the 1 is a subscript. So when you see a sub 1, that's how we pronounce it. A sub, and then whichever number it is. We can use any letter we want instead of A. A just represents the term. So A sub 1, that's how we pronounce it, A sub 1. That notation represents the first term in our sequence. Remember, our sequence is just the list of numbers. A sub 2 is the second term in our list. A sub 3 would be the third term in our list, and so on and so forth. We can go up to as many terms as we want. The notation used to represent any generic unknown term of a sequence is A sub n, n being the number we're not sure of yet. All right, 2 more examples, and then that's it for today. The common difference of a sequence is 5. Common difference is 5, and the sequence starts with the number -6. Find the terms A sub 2, A sub 3, and A sub 4. So our first term is -6. The common difference is 5. So this tells us that the first term in our list is -6, and we are counting up by adding 5s. So what we want to do is lay out a sequence that we can fill in with the given information. So A sub 1, our first term, is given as -6. we are supposed to find the next three terms. We are looking for term 2, a sub 2. We are looking for term 3, a sub 3, and term 4, a sub 4. Since our common difference is 5, we take our first term of negative 6, add 5, and we get our second term of negative 1. Then we take that second term, add 5, and get the next term of 4. Then we take that one, term 3, add 5, and then we can get term number 4. So once we know the first term, we can just keep adding our common difference to find any other term we want. Sometimes they're looking for a term down the line. So find the common difference of the sequence 48, 40, 32, and find A6. So to find the common difference, remember, we take the second term in our list, subtract the first term, and we get our common difference. So our common difference, we can check it a couple times to make sure it is a true arithmetic sequence. But once we have our common difference of negative 8, then we can go ahead and try to find the terms we need. We're going to use negative 8 as our common difference. And we know that we're looking for the sixth term in our list. A1 was given as 48. We already know that. A2 was given as 40, which confirms our common difference. We know that one. A3 was given as 32, which again confirms our common difference. So now we just keep continuing that pattern, keep subtracting 8, and eventually we get to the sixth term. So A sub 6 is the number 8. Now, if you want a little bit different way to do this same problem, because maybe perhaps the term we're looking for is way far up the list, and this may just take too long to keep doing over and over, there is another alternative. So another way to find our sixth term in our list is to, again, we're going to use the common difference, but we're going to apply it in a slightly different manner. So if you take the sixth term minus the first term, and the idea of using the sixth term is because that's the term we're looking for, friends. We're looking for the sixth term in our list. So from the sixth term to from the sixth term, first term to the sixth term, that's 5 terms in between. We already figured out the common difference is negative 8. So what we're going to do is take the number of terms that are in between where we start and what we're looking for. We're going to multiply it times the common difference. That's going to give us a number that we add to the first number in our list. And then we get the 8, just like we did before. So A sub 6 is the number 8. All right. Happy Monday, y'all. And I hope you have a good week. Enjoy your time off. And hopefully you're not too stressed out and you're all staying happy and healthy and safe.